In question 14, you're asked to factorise and then sketch the graphs. Now, before I can do that, I should really locate my y-intercept, which of course is going to be at the origin. We'll state it. I'm also going to have the general shape like so. That may help a few of you. There's not going to be a stationary point of inflection because it will factorise quite readily. So I'm going to find my zeros or my x-intercepts. Which becomes x squared into 9x minus 2 is equal to 0. So I'm going to have a double 0 at the origin, or turning point, and at 9 to 0. I now have enough information in order to sketch that graph. Not a lot of details required for a graph like this. Like so. A neat little question though to start off this exercise. In the next question, I've quickly listed the y-intercept and the shape. In order to find the zeros of the x-intercept, I've got to take out a common factor. So therefore, that happens when that's equal to 0. And therefore, x into 9x squared minus 4 is equal to 0. Now very quickly, I can find the fact that this is a difference of two squares to help me there. And I've got enough information in order to perform the graph sketching. So my graph will look like so. Now, in the next problem, I like rewriting that so we've got the overall shape factor happening, and I can more readily factorise it. Look, it's not that easy to factorise. I had to trial and error, so therefore x minus 3 is a factor. And it then becomes a matter of factorising it. So that gives me x minus 3. And I'll have to have an x cubed and a 1 happening there. After a bit of trial and erroring, we can see that that factorises to negative x minus 3 lots of 3x squared minus 1 is equal to 0. So that's actually a perfect square, believe it or not. So that becomes root 3 x minus 1 lots of root 3x plus 1 equal to 0. So therefore, x is equal to 3, x is equal to 1 over root 3. The answers might say root 3 over 3. And x is equal to negative 1 over root 3. Now, it's a bit of a ballpark as to where 1 over root 3 is. It's about 0.56, 0.58 I should say, and about negative 0.58. So that gives me enough information in order for me to be able to plot the graph, or sketch the graph I should say. So x and y, I'll have a 3, I'll have a positive 0.58, I'll have a y-intercept of negative 3, and I'll have a negative 0.58. So a graph will look a little like so. Slightly unusual, but definitely worthwhile persevering with. In this last case, I could do something about the shape. It should be x squared. Shape is going to look like so, and it looks like it should have 3 zeros. The y-intercept is going to be at the origin, or 0, 0. The zeros, or the x-intercept, to factorise that. And that comes down to x plus 3, lots of x plus 1 equaling 0. So I'm going to have zeros at 0, -1, and -3. And that becomes a relatively easy one to graph up. 3 zeros, 3 cuts. We don't, of course, have to find the turning point in this instance. Like so.